Welcome to lesson 87, comparing data. This is the very basis for something called ratios, which you're going to use a lot in 6th grade. Up on the board I have two numbers, and this says 4 red and 6 blue. Let's say that these are comparing data in my classroom. I have 4 students who have red shoes, and I have 6 students who have blue shoes. So I could just say, well, the comparison is every 4 red shoes, there are 6 blue shoes. 4 to 6. You could also write it out literally, 4, 2, T-O, 6. Or you could put a colon in the middle, kind of like a clock, 4, 6. That's 3 ways to represent your data when you have a ratio. Alright? Now, if you notice, the fraction form could be reduced. Yes, when you have comparison data, you will need to reduce your number. So 4 to 6 is really 2 to 3, right? Because you could divide both of them by 2, and that would leave this one with 2 and this one with 3. So it's 2 over 3, or 2, 2, 3, or 2, 3. That'd be 3 ways to write the comparison. Now, something funny happens when I ask you to tell me this the opposite way. Can you give me a comparison of how many blue shoes there are to red shoes? Notice if I say blue first, that's the number that I need to go on top. So 6 blue shoes to every 4 red shoes. Now this looks like an improper fraction. However, in ratios, you leave it in proper. You leave it. Because I want to know how many blue shoes to red shoes. Well, you always say that number first and you leave it on top. Okay? For every 6 blue shoes, there are 4 red shoes. And the reduced version of that would be the opposite of what we had here. So divide both of them by 2, you would have 3 over 2. Do not make it 1.5. I don't need to know 1.5. I'm trying to know how many blue shoes I have to red shoes. So for every 3 blue shoes I have in the classroom, I have 2 red shoes. Okay? So let's look at a problem that you have in your book. Number 1 and 2 actually go together, so let's do your whole homework. It says write a ratio for each and reduce if possible. There are 32 puppies and 48 kittens. 32 pups, 48 kittens. Okay? Automatically you should be noticing that there's a common number between these two, a common factor, right? Alright, which is 16. Yeah. Okay, number 1. What's the ratio of puppies to kittens? Now what did they talk about first? Puppies. That's the puppies, so you put that number on top. 32 puppies to 48 kittens. Now you can divide both of them by 16. 2 16ths fit in here, and 3 16ths fit in here. So your ratio of puppies to kittens is 2 to 3. Okay? For every 2 puppies I have 3 kittens, right? There's a little bit more kittens, so every 2, there's 3. So it's like on a war, there's 2 puppies, 3 versus 3 kittens. There's another 2 puppies, there versus 3 kittens. That's how the ratio is measured out. And number 2, what's the ratio of kittens to puppies? Kittens first to puppies. Well, wouldn't that just be the opposite of this? And if it's reduced here, the opposite of that would be 3 over 2. So the ratio of kittens to puppies is 3 over 2. Don't reduce it because it's asking for a ratio. Okay? Or don't make it a mixed number because it's asking for the ratio version. Okay? All right. If you have any questions about comparing data, this is the very basis of it. So get those questions out now and let me know if I can help. Thank you. Bye.